Wow, guys, section number 4 is one of my favorites and most interesting on my behalf, I will say. This is unit operations, but we're going to get more technical, more rigorous models. We're going to see more tabs. Yeah, those tabs that they are not required, and we're going to go inside them and actually input some data. We're going to see that, of course, when you add more data, you have a much robust result. Now, we're going to see 5 subsections. Number 1, separators. Simple, not that complex in my opinion. The B, or 4B, will be heaters. Actually, we are going to analyze more on the heat X. We're going to see the shortcut and a little bit on the rigorous methods. Then we continue with columns. We have seen previously on other courses the RAT-frac. You already know it's for distillation, but in this case, we're going to explore more on the distillation part. We're going to see how to convert a RAT-frac into a absorber and how to use the extract unit. Then we continue with 4D, which is the reactor part, one of my favorite ones because reactions, who doesn't like reactions? We're going to have 3 sections inside this subsection. First one is the stoichiometric reactors such as R-stoic and R-yield. Those are relatively speaking boring. Then we continue with the rigorous design, which are based on equilibrium. Those are the R-equil or equilibrium, I don't know how to say it. And then continues with the R-Gibbs. The reactor is based on the minimization of Gibbs free energy. Then we continue with, I would say, the most complex part, which is the reactors based on kinetics. The CSTR, continuous stir tank reactor, you know, it's a tank, you have an agitation system, and you just go input the materials, they react, and they go out. Of course, you need relevant kinetic data in order to verify how much time it's going to take, the conversion, and so on. Then we continue with R-plug, which is the plug flow reactor. We assume this is a tube. It can have several tubes. We're going to see that later on. And of course, you need the relevant kinetic data. And we see also the R-batch, or the typical batch reactor, which can be used as a batch system or a semi-continuous reactor. We're going to see a little bit on semi-continuous reactors. And finally, but not least, even though we always ignore or don't pay that much attention, is the pressure changers. We're going to be talking about pumps, compressors, how pumps can be converted into turbines and compressors as well, how we use valves, pipes, and the difference between pipes and pipeline. We're going to get much more technical on the friction loss, the type of valve we are using, the size of the pipe, the pressure drop, and so on. So guys, this is one of the most important parts. I think you already know. Most likely you are willing to study this part, the unit operations part. So without more to say, I'll leave you in section number 4.